with that because I'm not going to be in this class on Wednesday and I'm not going to be at school on Friday. So we really can't afford a relaxed day.
But
I am a chaperone, so I will be at prom, but it's technically a school day for me. I'm just doing school somewhere else. Does that count? Well, I am like the upper level math teacher, so we do like an HNAC math competition each year. So Friday is the grading day, so I get to go to Pioneer and grade like 700 math tests. So I'm super excited. And then Wednesday, I'm giving HNAC math tests here, so I won't be in this class. But today and tomorrow, we're doing this new lesson. Wednesday will be a work day for you to begin working on the homework if you haven't already. Thursday and Friday will be review days. You will take your test next Monday or next Tuesday, probably next Tuesday.
I'm hoping it's next Tuesday.
I'm planning next Tuesday. That way you have another day to ask me questions before you take it.
Yeah, because if it's on Monday, then I'll personally hate Mondays for all of eternity, which I already do hate Mondays.
Okay, so let's go ahead and get started on today's lesson. Pretty much. You just got stuck with me, so sorry. Oh, shoot, you're right.
There we go.
I was just so excited to start. This is solving rational equations. So it is taking what we did before and adding a third fraction to the mix.
That's unfair. It's just unfair.
So the example we're going to start with is 1 plus 1 over x equals 4 over x. What I need to do here is I need to get the left side down to 1 simplified fraction, and then I need 1 simplified fraction on the right-hand side, and then you're going to see something really cool that happens that will allow me to solve it very easily. So what I noticed is that this fraction already has a denominator of x, and this fraction already has a denominator of x. So what am I going to have to do to this 1 in order to be able to combine it with the other one? Put it over x. So what do you mean by put it over x? So it becomes 1 over x? No. Multiply it by x over x because x is the denominator that I need to make happen. When I do, I get x over x plus 1 over x equals 4 over x. Now that left-hand side is 2 fractions with the same denominator, which means I can put it together. When I do, I get x plus 1 over x equals 4 over x. And this is the really cool thing that happens. When I'm down to 1 fraction on the left and 1 fraction on the right, and the 2 denominators are the same, they cancel each other out. So then what I'm left with is simply what exists in the numerators, which makes it really easy to solve.
But you say that's not it, that we're not done?
We have to finish solving for x, but then we're done. So Ebony, how do I get x by itself in that equation?
Get rid of the 4.
Well, the 4 is already over here.
Get rid of the 1.
How do I get rid of the 1?
Subtract it.
And then I get x equals 3, and that is our final answer. So that's what we're doing today. We need to combine the fractions that are on one side of the equal sign. Then when I have 1 on each and their denominators are the same, they cancel each other out, and then I just have to finish solving the numerator. How bad does this look?
Seems very.
That's good.
It seems like this is going to get very hard very fast.
Very hard, very fast. Let's do another one and see.
Stuff like that.
Yeah.
I really feel like.
I feel very uneasy by the atmosphere we created in the classroom today.
Right.
If that don't match, just let's add one, right?
So.
Good thing I don't have to take math again next year.
Okay, so what we're going to do is we are going to identify what is shared between my denominators, and then we're going to create like denominators on all three terms. So I notice that I have a 6 and an x on the first one, I have a 6 on the second one, and I have a 2x on the third one. I need to break everything down as far as it will go. So I'm going to break the 6 down into 2 times 3 times x. I'm going to break the 6 down into 2 times 3. And then the 2x is just going to stay 2x. Why would I break that 6 down into 2 times 3? Because I will see that they all share this 2. So I need to break it down into whatever the smallest element is to see if they have it in common. So now that I've done that, I'm going to go through and I'm going to underline anything that all of them share. What they share doesn't have to get multiplied, but anything else does. So I noticed right away that they all have a 2 in them. So now what I need to do is I need to look at each fraction individually and see what I need to add into that denominator to make them the same. So this one is pretty complete. It has 3 different things going on. What is the second fraction missing?
X.
It's missing an x. So I can put an x into the top and into the bottom. What is my third fraction missing? A 3. So I need to put a 3 into the top and into the bottom. Now all 3 of my denominators have a 2, a 3, and an x, and nothing else. So they are ready to go ahead and be simplified. My first fraction stays 5 over 6x. My second fraction becomes x over 6x. And my third fraction becomes 3 over 6x. Now that I identified them as the same, I can put the 2 and the 3 back together, and then each of them contain an x. Are we okay with that? So now what am I going to do? Not until I do what, Pfeiffer? They can't cancel until I have 1 fraction on the left and 1 fraction on the right. Do I have 1 fraction on each side right now? No, I have 2 still over here on the left. So what am I going to have to do with those 2? Put them together because they have the same denominator. I'm adding them because that's an addition. So this becomes 5 plus x over 6x equals 3 over 6x. Now my denominators will cancel because there's 1 fraction on each side and they are the same. And then I just need to finish simplifying the numerator. So I have 5 plus x equals 3. Ariana, how am I going to get the x by itself? And when I do, I get x equals what? Anybody? -2. Yes, we will always have to combine 2. Correct. But it could cause a problem later on when we have much more complex denominators. Wishful thinking, wishful thinking. Okay, any major questions on this one? Did this kind of make sense? Kind of-ish. That's what I'm going for here.
That's what you're going for.
Okay. Some of you don't look so sure. Let's try another one then. So I have x minus 2 over x squared equals 2 over x plus 3 over x squared. Hannah, what do I need to do first? Okay, so I need to make them have the same denominator, right? So she already identified that my common denominator here is going to be x squared. Of course, I want to break down the denominators to figure out why, and then we'll go from there, okay? So I know that x squared is the same as x times x. This singular x is just an x. And this x squared, again, is x times x. I notice that my common denominator here is going to be to have all three denominators have two x's in them. So we identify the one that's missing x. She already said it's the second fraction. So what do I need to multiply into the top and the bottom to make that be the same? No problem. Nobody's seen me? Okay. So I know that I need two x's in my denominator. I recognize that this fraction is missing one. So Grant, what am I going to do to make all my denominators be the same? Into which part of the middle one?
Oh, actually.
Both parts, good. So I multiply it into the top and the bottom. Now all three of my denominators contain two x's. So I'm good to go ahead and start simplifying. So when I do, I get x minus 2 over x squared equals 2x over x squared plus 3 over x squared. Right, I just multiplied that x into the middle fraction and simplified them. What next? On the right side, good. How do I combine them, Pfeiffer? Perfect. So when I put them together, I just go ahead and add them. Go ahead and finish this problem on your own, please.
Yeah.
Who should I call on? Bailey, finish talking me through it.
I can be guessed.
Okay, well then you're the perfect person for me to call on. This is where we were at. So I had my left-hand side, and I was putting these two together. How do I put those two together? How do I combine them?
By addition.
Okay, so read to me or tell me what we're gonna have.
2x plus 3. Yeah, right. Then over your x.
Over x squared, good. Now what do I do?
This is what we're in. Combine
Who wants to help Bailey out? Cancel the denominators. Why can I cancel the denominators? Because they're the same on both sides of the equal sign. So that means they're gone. And what I'm left with is simply that numerator equation. Bailey, finish solving it out for us.
minus 3.
Okay. Anything else I would move, or is that it? Okay, let's see what we have. When I subtract the 3, I now have x minus 5 equals 2x. What do I do now?
Yeah.
How do I move the x?
Subtraction.
Okay, I'm moving this one, right?
Yes.
So now I have negative 5 equals x, because 2 minus 1 is 1. Anything else? What'd you say, hon? Well, I would have to if it was negative x, but since it's positive x, I'm actually good. Okay, so we are finished. X is equal to negative 5. How many of you got that on your own? Okay, looks like I need to start calling on this half of the room. Okay, Any questions so far? How bad was that? Pretty terrible? Not so bad?
It wasn't as bad as I expected.
Okay, so I'm gonna actually give you one to do on your own, kind of for the most part, and then we'll come together and go over it. I might be sending one of you to the restroom to see if he's in there. But I wanna send somebody he's not friends with,
Why?
because I wasn't born yesterday.
I don't do this.
He's like the lowest on my friend.
Yeah, I can see it.
The fact that he's on your friend totem pole though,
But it's the lowest when it's like they go.
It's the, I'm gonna make sure you're okay, then I'm gonna laugh.
Bailey, work, please.
That's the effort.
Grant, work, please.
Yeah.
Yeah, I can't like send you into the bathroom to look for him,
Hey, I can do it.
which kind of just leaves Cohen, but I don't want to take him away from math.
I know
so
where
we'll
he
see.
hides.
Oh, he hides.
Maybe, I don't know. I can find a note.
Do your math.
I think I got it.
Think you got it? Okay.
I'd be completely wrong, which probably. Wait. That's fine.
We're gonna do this one and then one more, and I think we'll call it a day after that one. Are you done, Ebony? Okay, keep working.
I just don't think that I did it right.
Okay, so how about you tell me what you did and we'll go through it, okay?
I multiplied x minus 3 to the 1 because it's a fraction.
Okay, do we multiply it just as x minus 3, or do we do x minus 3 over x minus 3? Over, just check it. So she multiplied x minus 3 over x minus 3 into the first fraction because it was the only one that didn't have the same denominator. So I just multiplied by what that denominator was. And when I did that, I get x minus 3 over x minus 3 plus 6 over x minus 3 equals 6x over x minus 3. Ebony, what next?
And I kind of combined it together. And I was like, hey, there's negative 3 and 6. You can combine them together and get positive 3.
Perfect. So what do I now have on the left side after I do that addition, Ebony?
X plus 3 over x minus 3.
Perfect. So she went ahead and added the two fractions on the left. So you should have x plus 3 over x minus 3 equals 6x over x minus 3. Ebony, what next, hun?
Get rid of the x minus 3.
Yep, because they're the same on both sides. Kaylee, finish us out, please.
I'm such a 3.
Why would you want to move the 3?
Wait, maybe subtract the x.
Okay, so I would move the x because there's already an x over here, but you could have moved the 3 and then moved the 6x. It would have come out the same way. So we're going to move the x. So when I move the x, what am I left with?
X equals, 3 equals 5x.
Then how do I solve for x?
By
By what?
the 5x.
Not the 5x though, because I want the x, right? I just want to move that 5. How do I move that 5? Because it's 5 times x, right?
So 5 to 5.
Divide the 5.
Where is?
So we're going to divide the 5 from each side. And when I do, I'm left with 3 over 5 equals x. So you should have gotten the fraction 3/5 there. Questions, concerns, or issues? No, we're okay? Okay, I need to go call Mr. Booker, and you guys are gonna start this next one.
Oh, hold up. This is betrayal and it's minus.
This is the last one that I will put you guys through today.
Is that right?
Go ahead and start it on your own.
This looks like a punch out.
Okay, so let's work through this one real quick. As I'm looking at this, I know that I need to break each of these denominators down into their base elements, but I have quadratics on two of them. So how am I gonna break those down? Say that again, hun. How am I gonna break these two down? I think you have the right idea. Can you say it louder? Sorry. Kind of close. So I think she's looking at the fact that both of the values in my quadratic contain an A, right? So I can actually pull a common factor of A out of each of those terms. And when I do, I'm left with A times A minus 1. Remember, when we have a quadratic like that, I have to treat the subtraction of those two values as one term. So I can't just take an A out of the first one. If I take an A out of the first one, I also have to take an A out of the second one. Does that make sense? So then I'm going to do the same thing here because it's the same kind of denominator. A squared divided by A is A divided by A is 1. So those turn into A times A minus 1. How was this helpful, Ebony?
It can work to help get the last fraction to A squared minus A.
Okay, so how am I gonna get the last one into a squared minus a, Ebony? How am I gonna make that a become a squared minus a? Well, what do I notice about all three of these denominators right now?
They all have one, or they all have a.
They all have an a. So this common a does not have to get multiplied in, but what they don't share has to be the same between them. So these both have an a and an a minus 1. What is this fraction missing? A minus 1. So that's what I need to go ahead and multiply into the top and bottom. The two on the left are already the same, so I can actually go ahead and put those together while I also multiply the a minus 1 into the right-hand side. So when I put these two together, I get 1 plus 16a plus 16 over a times a minus 1 equals a minus 1 times 1 is just a minus 1 over a times a minus 1. What am I going to do now? Madison. What do you mean by the two top ones? I'm going to get rid of the denominators first because they're exactly the same. So then I'm left with 1 plus 16a plus 16 equals a minus 1. Madison, how would I finish solving this? Okay, 16 and the 1 will become a 17. What else? How do I bring the a over? Subtract it, good. So now I have 15a plus 17 equals negative 1. Subtract the 17. Then I get 15a equals, what's negative 1 minus 17? Negative 18. So now I have 15a equals negative 18. What do I do now? Divide by the 15. Do I do it from one side or both sides, Camden? Awesome. Perfect. How did you get negative 6 over 5? Why did you divide both by 3? Perfect. So she got negative 18 over 15. She recognized that both of those are divisible by 3. So when she divided negative 18 by 3, she got negative 6. 15 divided by 3 was 5. You absolutely have to reduce your final answer if you can. So she got a equals negative 6 over 5, and that is 100% correct. Which part?
How'd you get negative 6 over 5?
Well, did you get the negative 18 over 15?
Yeah.
Then we took out a common factor of 3 from both of those. Any questions on this one? Okay, homework is on Canvas. You're more than welcome to go ahead and start it. In fact, I encourage it. Tomorrow we will finish up the last couple examples that we have, and then the rest of class will be homework time. Yeah. For